I got so. All singing low, while I pop a bottle off of your chain swinging, clang clang, and it costs a lot. Bitch, I'm always at the guala, yeah, and you are not badass beat. Keep on going till you hit the spot.
Assalamualaikum and hi everyone. Today we are going to explain crucial role of chromatography in forensic science. Chromatography is a powerful analytical technique used to separate, identify and quantify components in a mixture. In forensic science, chromatography plays a critical role in the analysis of evidence from crime scenes, helping to solve crimes and support legal proceedings. The principle of chromatography involves the partitioning of compounds between a stationary phase and a mobile phase, enabling the separation of mixture based on their chemical properties. Here is the importance of chromatography in forensic investigations. First, drug analysis. Chromatography is extensively used to analyze drugs found at crime scenes or in biological samples, such as blood and urine. It can identify the presence of illegal substances, determine their purity, and quantify the amount present. Second, forensic biology. Chromatography is used in DNA and protein analysis, helping to separate and identify biological samples that can link suspects to crime scenes or victims. Lastly, trace evidence analysis. Chromatography is vital for analyzing trace amounts of substance such as explosive, accelerants, gunshot residue, and other material left at crime scenes.
Now, let's look at application in forensic science. Theory. Chromatography relies on the differential affinities of compounds towards a stationary phase and a mobile phase. When a mixture is introduced into the chromatographic system, its components travel at different speeds, leading to separation. Various forms of chromatography exist, including gas chromatography (GC), liquid chromatography (LC), and thin layer chromatography (TLC) is suited for different types of analysis. Now, let's move on to another application of chromatography in forensics. It is drug analysis and identification. Drug screening and detection. Chromatography techniques such as gas chromatography (GC) and liquid chromatography (LC) are used to screen and detect drugs in various samples, including biological fluids such as blood, urine, saliva, tissues, and cyst materials. Drug quantification. Chromatography allows for the quantitative analysis of drugs present in samples, providing accurate measurement of drug concentration. This is crucial for determining the extent of drug use or exposure.
So let's move on to the material and chemical used in the identification of urine tests. Urine samples from individuals suspected of drug use. An organic solvent needed in this identification of urine test is methanol for extracting drugs from urines. GCMS system is gas chromatography coupled with a mass spectrometer. Chromatography column is used for splitting compounds based on their interaction with the column material. Mobile phase is inert gas used as a carrier gas. Standard solution is a pure samples of drug such as amphetamine, cocaine, THC for comparison, and data analysis software is for to process and analyze chromatographic and mass spectral data.
Methodology: sample collection and preparation. collect urine samples in clean, labeled containers from individuals suspected of drug use. Store and transport samples following appropriate protocols to maintain integrity. 2. Sample preparation for GCMS. Filter the extract solution to remove any particulates that could interfere with the chromatographic analysis. Concentrate the filter extract using evaporation under reduced pressure or with a gentle stream of nitrogen. 3. Detection and mass spectrometry (MS). Compounds separated by the gas chromatograph into the mass spectrometer. In the mass spectrometer, compounds are ionized and fragmented, producing mass spectra that are unique to each compound. The mass spectra are recorded and analyzed by the data system and software. Extraction of drug. Add an organic solvent, example given methanol, to the urine sample to extract drugs and their metabolites. Vortex or shake the mixture thoroughly to ensure all compounds are dissolved into the solvent. Chromatographic separation, gas chromatography. Inject a small volume of the concentrated extraction into the gas chromatograph. The gas chromatograph separates the component of the urine sample based on their volatility and affinity for the stationary phase inside the column. Compounds elute from the column at different times retention times, depending on their chemical properties. Data analysis and identification. Compare the retention time of chromatographic peaks and the mass spectra obtained from the sample with those or non-standard pure drug samples. Identify the compounds present in the urine sample based on their retention times and characteristic mass spectra. Confirm the confirm the presence of specific drug, amphetamine, cocaine, THC, by matching their retention time and mass spectra with those of non-standard. Example of result. Pick 1. Amphetamine. Retention time 7.8 minutes. Mass spectrum characteristic fragmentation patterns of amphetamine. Peak area 3,500 units. Peak 2. Cocaine. Retention time 10.5 minutes. Mass spectrum characteristic fragmentation pattern of cocaine. Peak area 4,200 units. Peak 3. THC. Tetrahydrocannabinol. Retention time 50.2 minutes. Mass spectrum characteristic fermentation pattern of THC. Peak area 2,800 units.
For the conclusion, chromatography is indispensable in forensic science for the analysis of complex mixture found at crime scenes. Its ability to separate, identify, and quantify substance makes it a vital tool in the forensic toolkit. With advancement in chromatographic technique and detection methods, forensic chromatography continues to enhance the accuracy and reliability of forensic investigation.